And number 8 is almost identical to number 7, with different numbers, of course, different problem behind it, I guess, except for one thing. You have to be really careful about the angles. So we'll look at that as we get to it. But I would still suggest you start a picture the same way. 600 miles per hour at a 250 degree bearing. And then we've got some wind. That's 80 miles per hour at a north 30 degree bearing. North 30 degrees west bearing. Okay, so first you do have to, I guess there's 3 things there. One is you have to know what the bearing is. If it gives you a direction, you've had more experience with that. But if it's just a generic bearing, you have to know that it is from north line measured clockwise. Always. North line measured clockwise. You might want to write that on your notes. So this would be a bearing of 90. This would be a bearing of 180. This would be a bearing of 270. So 250 would be a little bit less than that. And I'm going to update that angle. That much of a turn is 250. That will help us out later. If your bearing has no directions, it's from the north line measured clockwise. So there, 600 miles per hour. There's vector 1. Vector 2, I'm going to draw it. The start of it is at the end of vector 1. So I draw another XY axis, and north, turn 30 degrees towards west. So starting at north, turn 30 degrees towards west, like this. It's 30, and the wind is a lot slower, only 80 miles per hour. So if you draw it this way, the way I suggest you do it, you can see where you start, you can see what happens if you hit no wind, and then you can see where you get pushed to if there is wind. So you know your start and your end. So now we know the path. So if I had 5 seconds to answer this question, I could give at least a reasonable guess to the answers. To me, this looks a little bit longer than this. So the speed of the plane is probably a little bit more than 600. And if this angle was 200, 180 plus 21. If this angle was 200, and then this wind's pushing it up a bit, then the angle's going to be a little bit less than that, like 195 or something. So I have a reasonable ballpark before my answers are supposed to be without even looking it up. Scientifically, we need to be able to be much more accurate than that. So I can figure out exactly what the plane's doing by breaking it into component form. It's going 600 miles per hour. So 600 times cosine of the angle I plus 600 sine of the angle J. And I'm just putting in the arrows instead of I and J. And I'm leaving the angle blank for just a second, because I want to come back to that. I'm going to figure out how is the wind affecting it. So 80 times the cosine of the angle J plus 80 times sine of the I plus 80 times the sine of the angle J. I left that angle blank for number 2, because this is one thing that's different from question 7. And is probably the most common mistake for the quizzes and tests. You need to highlight this as something that you need to review. Alright, I know it's tempting to throw in 250 here. 250 is not right. 250 is the bearing. I'm about to type this in my calculator. My calculator has no idea that I'm wanting to do bearings all of a sudden. It doesn't know when I want bearings, regular bearings, north towards west bearings, standard angles. It has no idea. So it just has to pick one thing to always do. And the one thing that we always default to is standard. Well, standard position is from positive x-axis measured clockwise. That's what we do with the trig stuff. I drew it right. Do what I do now. Positive x-axis counterclockwise. So I know this is 90, and from this 250, I can figure out this is 20 more, so 200. You plug in 250, your calculator thinks you're heading at a different angle than you really are. So it's not giving you wrong information, it's just not giving you information wrong. Positive x-axis here. So this is 90, this is 90, so that's 180. And this bearing was 250. So this much of it was 90, this much of it was 180. If it had 3/4 of the way around, that would be 270. There's only 250, so I knew this last little piece of it was 20. Yeah, you gotta use that to help you find out what's wrong. Okay. And for the same reason here, you're tempted, and people will still do this, and I'm much I bug you about it, to say that this is 30 degrees. Think about what that's saying here. If I plug in my calculator, cosine of 30 degrees, what quadrant is 30 degrees in? So cosine of 30, I'm telling the calculator I want to go to the right. Well, we can see the wind doesn't go to the right. It goes to the left. You've got to tell it the right angle. So on the positive x-axis, measured counterclockwise would be 90 plus that 30 minutes. So be extra careful with that stuff. Write a note on your page, highlight it, bubble it in, whatever. The angle has to be from positive x-axis. Now, I didn't have to say anything about that in the last question. Let's glance up at it. Because the angle 60 degrees was from positive x-axis and negative 15 was from positive x-axis. I didn't need to do anything else. Okay. So there's the second difference with this question. But I still want to add another. So if I take how much this one's going right or left, plus how much this one's going right or left, I'll figure out what the total is, right or left. And this half only has cosine stuff in it. If I take how much this one goes up or down, and I add to it how much this one goes up or down, and I get the total of how much it goes up or down. And maybe most important, so that you're not getting lost in all the writing, how much in total it goes left or right should be able to be visualized in your picture right there. Going that much to the left. I'm going to store that as X in my calculator. This is the total of how much is going up or down. And if you've got your picture there, you can visualize that. That would be Y. Every time, if you have horizontal component and vertical component, those have to be perpendicular to each other, so it has to give you a right triangle, which means if I want hypotenuse, which in this case is the magnitude, which in that case is the speed of the airplane, I would take the square root of leg squared plus leg squared. I'm going to let my calculator do the computation part. And if I want to know the angle it's going at, I will find this angle by asking my calculator to do inverse tangent of y over x. I'll cover adjacent. And sometimes we add 180, sometimes we don't, but we need to consider these times. So since the range of inverse tangent is quadrant 2 and 4, and this guy's going down in quadrant 3, I know I'm going to have to add 180. If you don't want to have to recall that stuff, you'll just see what we get when we type in the calculator. You should see what it doesn't make sense. So that's how much it's going right or left. My picture shows it's going left, so it makes sense that it's negative. That's how much it's going up or down. It's negative because it's going down total overall, so that makes sense. And again, hypotenuse is the square root of a leg squared plus a leg squared. And since I stored those, very easy to type in. So before I even started this question, I told you I could eyeball it and see it was going to be a little bit more than 600. So 618 miles per hour completely reasonable. That wind's at its back, so it's going to help it speed up. The wind had been in its face, so it would slow it down a bit. An inverse tangent of opposite over adjacent would give me the angle. But it's saying the angle is about 13 degrees. The problem with that is 13 degrees is in quadrant 1. I'm in quadrant 3. So it's giving me the other angle on the other side of the unit circle that has the same tangent value. So in this case, we have to add 180. But that's the third difference between question 7 and question 8. Sometimes you add 180, sometimes you don't. If you have a picture, it should be pretty obvious whether you need to. Okay, so I know you already practiced this question, and then you looked at my solutions online and tried to learn from those. But now that you've heard it explained out to you again, which I guess is kind of like the third time. One time will be the notes. This is kind of the second time, and this is kind of the third time. Any of that you want me to go back and talk about again for the 120? So anytime you plug an angle into a trig function, it's assuming standard position. We don't put bearing in the trig function. So that's the positive x-axis. So here's my wind. Here is the positive x-axis. And you measure counterclockwise, like we did all the big stuff last night. So from here to here would be 90. That's one quadrant. And then based on the bearing it gave me, I knew this was an extra 30. So 90 plus 30 gave me the 120. Whatever the bearing, just because you're not using the, you don't get to put the bearing in directly, it's going to be part of what's going to be used. Good question. Somebody else have another one? And